I'm Sylvia Hartmann. I'm a member of the organization team and deputy chair of the German Alliance for Climate Change and Health. And today we're going to start our series with an introduction about climate science, biodiversity, and planetary limits. And we're very pleased to have Professor Stefan Rahmstorf from the Potsdam Institute and Professor Settele from the Helmholtz-Centre for Environmental Research. And we also have Professor Sabine Gabrysch, who's the first professor for climate change and health in this combination at the Charité. I would like to pass the floor to Martin Herrmann, my colleague, who's going to tell you something about KLUG before we're going to start with the topics. So much for myself. I would like to pass the floor to Martin. Hello. I'm also an organizer and chairman of KLUG. Martin Herrmann is my name. Pleased to see you all. And I'm going to say briefly something about KLUG. We are the organizers of the Planetary Health Academy. KLUG was founded in October 2017 by 15 people, 5 students, then 5 people who are active in work and 5 retirement persons, and the topic was to look at the crass imbalance between the health threats through climate change on the one hand, and on the other hand, the ignorance for this subject in the German health sector, and to make sure that we are going to talk about the climate crisis as a health crisis, and we educate people about that and make them do some transformative action. And I'd like to welcome Sabine Gabrysch, who is a founding member and the first professor for climate change and health at Charité. And she's also an example of great connection and cooperation between the different researchers and research institutions. And she is also introduced the idea of planetary health into our work, and I would like to ask you to set the frame for us. Thank you very much, Martin and Sylvia. In 2 weeks, we're going to have the seminar on planetary health. I would like to mention just a few things about the context of the series. Why do I think planetary health is so important and so cool? Medicine is, of course, very much dominated by the biomedical perspective, by the microscope, and the health causes are analyzed in terms of the cells and genes, which is not wrong, but it's simply not complete. You also need a macroscopic view in order to really understand the basics of health, understand people's living circumstances, diet, the quality of air, water, and so on. Anyone who's been to a poorer country will immediately understand that it's poverty which makes people sick, for example, because of contaminated water, and it's not enough to treat people. You actually have to change the circumstances which make people ill. Public Health is quite proud that some diseases have been reduced and eradicated because of improvements in public health. 200 years ago, sewage water was simply dumped out of the windows into the gutters and stank. And the creation of sewage canals was a great progress, and then this turned into global health, and the causes of diseases were analyzed, diseases which go beyond borders, where global cooperation is necessary. And now what it takes is another expansion of the perspective above and beyond the human-made social and political systems to include the natural systems of the whole planet, which is the basis for global health or planetary health. So in a similar way in which people dumped their sewage into the streets without worrying much, we are now dumping our pollutants into the atmosphere, which heat the climate. We dump plastic onto the world as if this was a rubbish tip, the whole world, and this is destroying our livelihoods. So planetary health adopts the most broad-based macro perspective and looks at the question, what are the basis for our livelihood? So what is planetary health exactly? On the one hand, it's a discipline which is building on public health and global health. So it's a transdisciplinary discipline because it goes far beyond health sciences. On the other hand, it's also a movement. The issue is to improve the world for the better, and here Health for Future comes in, and the motto of our seminar series, From Knowledge to Action. In 2014, in Lancet, there was a one-page manifesto published, which was called From Public to Planetary Health, which creates a great diagnosis of the status of of planetary health. It's about social justice, power, trust, the crisis of a democracy and the value system, our relationship with nature, environmental destruction, climate change, and also points to a positive vision. I would like to encourage everyone to read this manifesto. It's also available on the Planetary Health website. And number 3, planetary health is also very comprehensive subject. Is not just about climate change and health. Climate change is just one aspect, even though it's a very central one. And in the climate crisis, apart from the climate crisis, we also have other crises, such as a massive loss of natural ecosystems, biodiversity, the pollution of water and soil, and everything is connected globally. And the corona crisis really brings it very clearly home to us now. And when it comes to a disease, it's not enough to treat the fever. You have to also treat the liver, the kidneys, the immune systems, and look at those systems as well. And the Earth, as such, is a complex system, and it's almost like a living organism. The physiology of the body involves the breathing and the circulation and so on. And the Earth system, sciences looks at the atmospheric circulation, the water circulation, and so on. And this brings us to the subject of the first presentation today, and also the first speaker, Professor Dr. Stefan Rahmstorf, who is a physicist and an oceanographer, working at the Potsdam Institute for Climate Impact Research, one of the best researchers in this field globally. Also is very committed in the public discourse about climate research in the classic media, also on Twitter, in the form of blogs, for example, the Climate Lounge. And he also has created expert opinions called Social Contract for Transformation, which will come back into in the next seminars. Instead of listing all his awards he's won, I would also like to mention that 20 years ago I met him for the first time in a summer academy on the subject of climate change in St. Johann in South Tyrol, and I was a student in Tübingen, and now since last year I'm also at PIK Potsdam, and I'm very glad to have these great colleagues, and thank you, Stefan, for taking the time to talk about planetary health.
Herzlich, Stefan, dass du dir heute Zeit nimmst für unsere Planetary Health Academy.
Thank you very much, Sabine, for this very kind introduction. I would like to try to use the 30 minutes for me to lay the foundations and give you the most important facts on climate change. And hopefully technology will not let us down. So first of all, let me try and switch my presentation. That's great. Right. This picture was taken by the space probe Cassini a few years ago before it entered the atmosphere of Saturn, and it basically died there. And I'd like to show this picture because the photograph shows the view back to Earth. This is Earth, which is floating through space, it seems to be quite lonely, and it's protected by a wafer-thin atmosphere from this very hostile environment. Our atmosphere is just as thin as an onion skin compared to an onion, but still everything we thrive on is on Earth, and basically it's the only home we have available for us for living. And this planet is not unlimited in size, obviously, and there are a number of stress limits to its survival, the so-called planetary boundaries, which we should not go beyond without or which will not go beyond without really running massive risks. I don't have the time to address all these individual limitations, but at the very top you see climate change. Then to the left of that, the integrity of the biosphere. So here it's about the threat to biodiversity and the livelihood we have. Then we have other factors which haven't been fully researched, also not in terms of critical limits, for example, the smog in the atmosphere. I'd like to just to mention that according to the WHO, every year 4 million people die because of pollution. Not in the home, but pollution of the atmosphere, of the air, which is mainly due to the burning of fossil energies. I'd also like to point out acidification as an oceanographer, because it's also just caused by human pollution, and for time reasons I cannot elaborate on these further. But the main point today is the basic facts on climate change and the fact that humans can change the climate. That was known by Alexander von Humboldt in 1843, because he said humans are changing the climate by deforestation and because of the creation of great masses, large masses of vapor and gases by industry. And he was very foresighted and farsighted at the time. He was much ahead of his time. What he could not know, however, was that carbon dioxide is the main greenhouse gas, even though the greenhouse effect was known in 1843, but it was sometime later when lab experiments showed which gases are causing the main causes for the greenhouse effect. And the beginning of exact measurement of carbon dioxide started with Charles Keeling in the 1950s. And ever since then, we've known how the carbon dioxide quantities in our atmosphere is rising. We can see here this famous Mauna Loa curve, and because of the ice cores analysis in Antarctica, we can go far further back, 1 million years back, and we know exactly what the CO2 concentration has been over thousands of years. In the last tens of thousands of years, we had the Holocene period, and this was the period of human civilization. And we can see that the rise of CO2, the values we're reaching now, more than 400 ppm of CO2, these are the highest values, or levels rather, for more than 3 million years. And we can see also this figure 2 watts per square meter. This is the so-called radiative forcing. So this is the heating power which is caused by the rise in CO2 per square meter of the Earth's surface. This is the reason why it's getting warmer. This is where the heat energy is coming from, which drives global warming. This is the comparison between the various changes in this radiative forcing situation, and the man-made radiative forcing amounts to about 2 watts per square meter, roughly. I'm saying roughly because we can measure the radiative forcing because of the rise in CO2 concentrations, but then there's also other factors. Man also causes other changes in the energy balance of our planet because of further greenhouse gases, but there are also cooling effects, such as the aerosol pollution of the atmosphere, which keeps away the solar radiation. It has a cooling effect, and also there are other effects, the indirect effects, however, have a very small impact. So weak cannot really exactly determine the human-made radiative forcing, but it's certainly much larger than natural changes in this radiative balance, such as changes in solar activity and changes in volcanism. Those are the main factors. And these natural factors, over the last 100 or 200 years, they have had a slightly reducing effect, a cooling effect rather. So they have counteracted the human effect. So as climatologists, we can say that global heating is completely man-made, and this change in the radiation budget of the Earth is no theory. It is measured constantly at the upper edge of atmosphere by satellites, and also at the ground because of the worldwide network of measurement stations. And this increase of long-wave back radiation, all this is happening exactly the way the physical theory has predicted. So it is very well proven, and it's not controversial between scientists. Of course, in the media, the picture is slightly different because there are massive lobby interests trying to confuse the picture, and they can be documented, has been documented in this book by Naomi Oreskes and Eric Conway, Harvard scientists, and they document the fact, which I find interesting, that it's the very same people, the very same PR agencies, which have rejected or denied the harmfulness of smoking, the same agencies which will also deny the harmfulness of greenhouse gases. And it's the same people who are currently arguing that the coronavirus is harmless, and it's as harmless as a flu. And it's very interesting for us as climatologists to see that it's the same argumentative tricks used, the same kind of cherry-picking the data. It's done by the same people who are trying to discredit climate science, who are now discrediting coronavirus basics. So sometimes these people are also close to AFD or other right-wing organizations. Going back to serious scientists, the first person to calculate how much heating will happen in certain changes to the radiative budget was Arrhenius. This is what we want to know. We want to know how sensitive our planet will react to changes to the radiative budget. This is called climate sensitivity, and Arrhenius in 1896 calculated in this great publication that a doubling of the CO2 quantity in the atmosphere will result in global heating by 4 to 6 degrees. And something he thought was cool was he suggested that we should all ignite the coal seams in order to raise the global temperature. After all, he was a Swede. Also, he was married to a woman called Thunberg, who was a distant relative to Greta. Now, if we know this climate sensitivity, we can also calculate how much heating humans have caused so far. And this is not a technical problem, which someone suggested recently when I made a distant presentation in the US last week. But this is the actual heating which happened. This is the more conventional way of displaying this, but each colorful band reflects the temperature in 1 year ever since 1880, and the darker blue bands are cold years and the red ones are hot years, and we can now say that there's been 3 degrees increase if there's a doubling of CO2, and we can therefore calculate that we should have caused an increase by about 1 degree so far, and the actual increase is 1.2 degrees. So this model was quite correct. After my birth, I spent the first 20 years in exclusively blue years, cool years. Someone who is now 20 years old will have spent all his life in these red years. The warnings against this global heating, the first official one by an American was caused by an American expert body in 1965. This was initiated by Roosevelt in the form of this Revell report, and it wasn't known that there is an actual increase in temperature. But in 1988, the famous climate scientist Jim Henson said this in a Senate hearing, as reflected in the New York Times. And I can well remember this was during my PhD thesis, and at the time, amongst the conservative professors, they really raised their eyebrows slightly whether Hansen was really sticking his neck out too much and whether this could really be down to natural fluctuations of temperature. But now the increase in temperature has progressed to such an extent that every serious climatologist is convinced that the predicted global heating, which by the way was also predicted by the company Exxon internally, it simply didn't publish it, but that this heating is completely explainable by physical effects. Stefan, there are these dropouts in the sound. Maybe it's a microphone problem on your part, whether you can do something. We can follow your presentation, but it's difficult for us to follow it. Well, unfortunately, I can't really do much about it. It must be due to the link. So the best thing I think we can do is continue. We have to live with it. So I'll just continue. Well, you just go ahead then. It's okay. Well, what you can see here is the fruit of decades of paleoclimatology. Paleoclimatologists, they drill ice cores in Antarctica, Greenland, and on glaciers, and also in the deep sea. And we've now got enough of these data to say something about the development of global mean temperatures since the beginning of the last ice age, 20,000 years ago. And we can see that there is an increase of about 4 degrees between the ice age and the Holocene. Afterwards, for about 5,000 years, there is a very slow cooling effect. And the reasons for that are so-called Milankovitch cycles. We can see this cycle with a period of 23,000 years. And we can see that in the space of 100 years, we have exceeded the cooling effect of the last more than 5,000 years. So the temperatures now are above the level of the middle Holocene. If we didn't have these data, we'd still know that we are undergoing dramatic change on Earth. Just take the look at the ice sheet on the Arctic, in the Arctic Ocean. This is the picture from the 1960s, 1970s, and this is what it looks now in recent years. And I think most of those who are listening to us will also see this situation. Will for the first time have an ice-free summer on the Arctic Ocean. We don't quite know when exactly this will happen, but it may certainly happen in the next few years. In the last decades, we have lost 3/4 of the ice volume in the Arctic Ocean in summer times. What are the effects on humans? Of course, it's mainly the extremes which hit us, less so the mean temperatures. So the typical example was the summer of the century, so-called in 2003. Europe-wide, the mortality statistics measured or counted 70,000 deaths caused by heat. And we can see the distribution of summer temperatures since the year 1500. There is a frequency distribution between the cold summers on the left and the warm summers on the right of this distribution curve, and you can see that the recent years since the turn of the millennium are far to the right of this normal distribution. Otherwise, the normal distribution is really like a Gaussian distribution, and the hottest summers are listed here. So it doesn't take a Nobel scientist, Nobel Prize winner to see that this is not an accidental distribution. It's down to excessive heat, and the heat records are far more frequent than they used to be. I mentioned mortality during these heat waves is very high. In 2003, the morgues in Paris were overcrowded, so there wasn't space for the corpses to be housed. And there was a recent study, I think from last year, in the Lancet Planetary Health, and it shows that the dependency of mortality from on temperature, and you can see 2 German cities, and we've done the same thing for many other continents. What's relevant here is the red part. There is an optimum temperature where mortality has a minimum, and there is a very steep rise into the red sector, into the hot temperatures. And the problem is, if you look at the frequency of the day, number of days in the gray bars at the bottom, if it's shifted to the right because it's getting warmer, then the more frequent days will slip into the sector of rising mortality. So this cannot be compensated by mortality on the cold side, because the curve is much flatter on the cold sector. And yesterday there was a publication in Financial Times which looks at the excess mortality figures due to COVID-19, and I've seen an interesting curve there, which I have also looked at and worked on ever since the heat wave in 2010 in Moscow. In red, you can see the rise in mortality through COVID-19 in Moscow, where there are huge problems with COVID, as compared with the previous 10 years, which are the gray curves. And in one of the previous years, 2010, there was a huge peak above the average mortality in Moscow, which is this very hot summer 2010, which had its focus in Eastern Europe, whereas the year 2003 was there. The focus was on Western Europe. Another extreme which increases through global heating is extreme precipitation. This is physics, because hot air can hold more vapor, and it can also rain more. And you can see that the daily sums of precipitations rise massively, and these are events like this. In Braunsbach, for example, some years ago, this is what happened. So it looks like a science fiction movie. You think, well, this is a bit exaggerated, but actually it's reality which someone has filmed with a smartphone. Another consequence of global warming is the increase of droughts. One reason is the soils will dry out, higher evaporation rates, and many global regions see a decline in precipitation in the Mediterranean, for example. These are data which show that in the last decades precipitations have declined drastically, as was predicted by the climate models. I can also see that Syria is very much hit by that. And in the years before the mass protests in Syria, this country has been through the worst droughts of its history, which caused a lot of cattle dying, 1.5 million domestic refugees, and which was one reason for the huge unrest in Syria. And this is a study which makes the link not just between global warming and extreme drought, which under sediment data is the worst drought in 900 years in the Eastern Mediterranean, but also a link to the political unrest in Syria. And we all know what the upshot of those unrests was. Another example of these extremes is the risk of forest fires in California or in Australia, as we've seen it this year. The IPCC also has pinpointed this effect for Australia and predicted this effect with a high likelihood that these bushfires would happen, and also in Brandenburg in Germany 2 years ago we've seen similar bushfires or forest fires. Another effect of global heating is the melting of continental ice. The loss of continental ice, as you can see here in the satellite picture from NASA, also in Antarctica, where it's more localized because the Antarctica is on the pole and it's very cold. But it's losing ice mass, which means a rise in sea levels. And you can see the rise of the sea levels here in the last 300 years. As a consequence of global heating, the sea levels have risen so far by 20 centimeters, and according to the scenarios of the future, we are expecting a further rise of between 0.5 meter and 1 meter up until 2100, which will be the beginning only of a long-term rise in sea levels lasting many centuries. It will take a long time until global heating will be reflected in the sea levels, because the sea takes time to expand. The continental ice masses take centuries to really fully melt. And so there has been an increase of 4 degrees since the last ice age, which was reflected in 100 meters rise in the sea level. There is enough ice on the continent in order to raise the sea levels by another 65 meters. So we cannot afford to even lose a few percent of the current continental ice, but we are moving towards an increase of 2 to 3 degrees. And the IPCC expects that at low emissions, based on the Paris Agreement, we can limit the rise of the sea level to 1 meter by 2300. But if we have high emissions, we're going to end up with 4 meters higher sea levels. And what this would mean for these islands, for example, this is Male, the main island of the Maldives. You can imagine that large areas of coastal areas are very hard to protect from rising sea levels. I would like to say a few words on tipping points. Ice sheets are one of these tipping points because they have a critical temperature, especially the Greenland ice, but also the Western Antarctica, where ice is destabilized, and without further heating, there will be an automatic avalanche, basically. This is also shown in the computing model. The Gulf Stream has such a tipping point, which was known since the 1960s, and this is a simplified view of this stream system, the Gulf Stream. You can see that a hot superficial stream is flowing north and passes off the heat to the air, and it comes back to the south as a cold flow. And if you use the climate model, where we can see these Gulf streams And if you increase the CO2 concentration, then you can see the very interesting temperature change pattern in the North Atlantic, a cold spot south of Greenland, and heating up in front of the North American eastern coast, which is a dipole. And in our model, we can show exactly what the reason is, because we have the full information about what's happening in this model. And so this is what happens in this climate model if there's a weakening of this Gulf Stream. Mr. Caesar has spent years on calculating this, looking at the global ocean surface temperatures as to how they have changed in the last 100 years. And this is what they have done. You can see that these lines are not as sharp because of the limitation of the measurement data, but I can see the same dipole patterns in the North Atlantic, which is a kind of fingerprint of the fact that the Gulf Stream is weakening. We are convinced that the Gulf Stream system will weaken the same as predicted by the climate models. Now, when it comes to the future, well, to calculate the future, we need these climate models, so you can see what the atmosphere looks like in such a climate model. This is also modeling by NASA in this case. And in these models, we can play around with different scenarios with more or less CO2 emission, and what we end up with is different heating levels. The blue scenario is the Paris scenario, or compatible with Paris. So we would keep the global heating below 2 degrees. The red one, which would be the worst case with much higher rising temperatures. And I think we'll end up somewhere in between these two extremes. And hopefully we will be able to implement the Paris Agreement and end up close to the blue path below the 2 degrees limit. Let's take a look at the global distribution of temperatures. This is a scenario with a 4 degrees rise. At the moment we don't see much because global heating started only in 1980, roughly. And currently what we see is natural fluctuation. But after the turn of the millennium, we're starting to have more red colors. We can see a very high increase in temperature in the Arctic Ocean. And now we start to see heating in the land areas also, which has simple physical reasons. They are down to the thermal inertia and evaporation, and which means that in this scenario the mean increase in temperature is 4 degrees globally, that in the land areas where we live, where we also cultivate our food, we're talking about 6 degrees and more. But in order for the 2 degrees scenario, it means we're talking about 3 to 4 degrees increase on land. And this is sometimes being ignored if we discuss mean values, global mean values. Finally, a few words on the counteraction. Fortunately, we've got the Paris Agreement, which is a historic feat, but the main weakness is that we should have done it 20 years earlier. Then the emission by greenhouse gases could have been reduced. But now we have to have a very steep decline, as shown by this graph, which we have developed together with Christiana Figueras and others some years ago. You can see these 3 solid curves end up with the same heating effect, but their difference is only how steep they are, so how quickly you change to reducing the emissions. And what's important is the total budget of the CO2 emissions. So it's the area under the curve, basically. So if you start later reducing emissions, then you have to go down to zero earlier, so the curve becomes steeper from both ends. And if we can only start in 2025, then within 10 years we have to go to zero emissions from the maximum, which is not going to be possible. But if we can reduce it by starting in 2020, then we have enough time until 2040 to end up with zero emissions, net zero emissions. Even in 2007, we have come up with an expert opinion and said that by 2020 we have to start reducing the global emissions, and Bild Zeitung has come up with a great cover page on that. So how about the actual emissions in Germany? In blue we have the actual emissions, and green would be the path which ends up below 2 degrees. If you assume that according to the German population we get a residual budget under the Paris Agreement of a certain number of CO2 emissions, then compared with that, we have the dotted line, which is the goals by the federal government, and so we would emit about twice as much as we would be allowed to emit under our budget. So the goals of the German government are far away from climate justice and from making a contribution to the Paris Agreement. Also, when it comes to the emission reductions, we are only quite middle ranking, or quite down on the list. There are many countries in the OECD which have reduced their CO2 emissions much more strongly, because sometimes you hear that Germany can't be the only country reducing emissions, but that's not actually true at all. In order not to end on a pessimistic note, as a last slide, I'm showing you this, which is the electricity generation in Germany last year, and we have produced more renewable than fossil energy. So on the left-hand side you can see the detail of the renewable energy which we have produced. So the lion's share of renewables is wind and biomass and solar electricity and a little bit of hydro also. But unfortunately this has not been enough to bring down our emissions as quickly as we should have done, because this is only electricity generation and we're lagging behind, especially when it comes to transport and heat. And also we have created a lot of renewable energy, but we have forgotten to the fact that we're exporting electricity to other countries. Obviously, why should a utility not create electricity when they can sell the electricity? So this is a political question relating to the exit from coal. Now this brings us to a few conclusions. The climate crisis real. We have caused it. It's become very urgent, mainly because of decades-long debating and waiting, and decades of lobby work, trying to confuse the public, general public, and trying to suggest that there are some scientific doubts about this, which is not true at all. And the consequences for us humans relate to extreme events, failed harvests, and so on. And these consequences will massively rise, also mainly because of the rise of the sea level. So that's why it's so important to actually implement the Paris Climate Agreement as consistently as we can, and at the latest by the middle of the century, or if better, or ideally if earlier than that, we should arrive at zero emissions. So we have to halve the global CO2 emissions in the next 10 years. And so what politicians and what the government has done in this field is by far not enough to do justice to the climate crisis, and we can only hope that the positive experience in many countries with the corona crisis, where decisive governmental action was able to reduce the case numbers, and that this can be transferred to the climate situation. Governments will notice that if they follow scientific advice and if they take consistent action, then they can actually make a difference. So we are not completely helpless when it comes to the climate crisis. We can make a positive change. Thank you very much. Thank you very much, Stefan Rahmstorf, for this very clear presentation of the situation from the point of view of a climatologist. So I'm very pleased to pass the floor to Professor Settele. Professor Settele is from the Helmholtz-Centre for Environmental Research in Halle, and he is chair of the Intergovernmental Platform of Biodiversity and Ecosystem Services, IPBES. It's analog, or similar to IPCC, so it's the most important global council for biodiversity issues. I'm very pleased about the fact that you have given us your go-ahead to come and have a presentation at short notice. So, Mr. Settele, you can start your presentation and take over. Well, thank you very much for the invitation. I'm co-chair of the global assessment of the Global Biodiversity Council. Otherwise, I'm working at the Herrmann for Environmental Research in Halle and the German Center for Biodiversity Research in Leipzig. So I'm going to give you an overview over what we have found out in our global assessment. This is the global assessment of the World Biodiversity Council, show you some core results, and also at the end talk about the corona crisis and the link with the ecosystem. The Global Biodiversity Council, called IPBES, is the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, and the mission is to improve the knowledge base for better policy in science for the maintenance and usage of biodiversity and better global well-being and sustainability. It is an independent intergovernmental organization with more than 130 governments. It cooperates with international associations and organizations, and is based in Bonn. And the global report of the Biodiversity Council was published in May 2019, and it is similar to the IPCC reports, based on a long process with many drafts, cooperation between different experts. More than 100 people have been involved in this report, and the elements I'm going to show you today are a summary for policymakers. They are statements which are based on consensus with the global community, and they were adopted last year. This was the team. These are the core authors, 150 people, and we had the honor to chair this. I'm on the bottom right, then Ms. Sandra Diaz and Mr. Brandisio. Eduardo is an anthropologist. Sandra Diaz is involved with botany and plant sciences, and I am basically an entomologist. But for many years I am active more in the field of land use. So a few core messages. The biosphere, atmosphere on which humanity depends, has been influenced seriously by man. 75% of the land surface has been changed. 2/3 of the oceans have been impacted, and 85% of the wetlands have got lost. We have looked at the extinction events globally, for example, a few graphs for known vertebrae since 1500, and we can see in the last 100 years the extinction rates have gone up. Reptiles, 2.5% extinct species, and most of these species have been lost in the last 100 years. Globally speaking, the global extinction rate is 10 to 100 times more quicker than in the last 100 years. This is the background extinction rate, gray bar. There's always been some extinction, but it's much more limited than we have it today because of human activities. And we also gave an estimate about the threat of biodiversities for animals and plants globally. And one basis for that is the IUCN, the threat of different types of species. On the blue bars, you can see the percentage of threatened species, which is between 10% and 65% for the ferns. And for these species which are well known, of these species, a quarter are threatened with extinction, roughly speaking. There are about 1 million species which are threatened, and the reason is that we have 5 to 6 million species of insects, and we think that the extinction rate for insects is slightly lower than for vertebrates. But we end up with a figure of 1 million roughly. This is a publication in Zeit magazine. So 3/4 of the land surface is impacted, 1 million species are threatened, and only 7% of the fish stocks are treated sustainably only. We also have looked at the function of the ecosystems, and we have evaluated 18 categories. They are the so-called regulating ecosystem functions, and the arrows show whether it's negative or positive. And we can see, for example, the creation of habitats negative. The second is the trend of pollination and spread of seeds, also a negative global trend. For other functions of the ecosystem, such as the air quality, the trend wasn't as negative, but it was slightly negative. And there are some services or functions which we can classify. We have some positive functions, such as we're producing more food and fodder, or the potential surface for food and fodder is rising. So for carbohydrates, we have made progress, and for other things, we have negative impacts. For example, culture, education, inspiration, negative trends. And then at the very bottom, options for the future, which come for the future. So we think there is a negative take on the survival of species and the phylogenetic diversity, which is also going down, which links up with what we said initially, that there is a reduction of biodiversity. The development of ecosystem functions is the potential of nature to contribute to a positive, sustainable quality of life, and this potential of nature has dropped in 14 out of 18 factors. Further aspects about agriculture, these are snapshots of the summary for policymakers. 30% of global food production are provided by small farming, smaller than 2 hectares, with rich biodiversity. Also, a third of farms implement sustainable agriculture, which is only 9% of the total surface area. On 33% of the agricultural area, the yields are going down through degradation. And the last 2 points, well, 68% of the capital of the soy and beef production, 70% of the capital in illegal fishing go to illegal tax havens, where we have serious aberrations where we have to make a change. And OECD states are subsidizing agricultural production with $100 billion, which is not environmentally sustainable. This has been a consensus between 130 governments, this statement, by the way. Now for the human impact, direct drivers, which have changed the globe. We have distinguished this by land, water, and other habitats. And we can see the main driver is the changed use of land and seas. Then there is direct exploitation, for example, deforestation or fishing. And the third aspect is climate change, which is also an important driver for the change of the globe of Earth. Then we have waste, plastic, invasive species, and others. What was the most important aspect for us in this analysis is the analysis of indirect causes. So the question was, what are these indirect drivers which are based on behavior, where the issue is how can we achieve transformation, which is also part of your seminar series. Then we had scenarios for transformative change, which show that the goals for sustainable development by 2030 and the 2050 vision for biodiversity could be achieved, but only if we have transformative change. And the main elements for that is change of the production and consumption of energy and food, then reduced population growth, and nature-friendly and socially fair climate adaptation and mitigation. So the issue is to think about biodiversity and climate at the same time, in combination. How much surface area do we need for what, and where is the focus? Biomass could be used as energy carrier, could be used for food. Now, in the context of IPBES, we have defined transformative change as reorganization across technological, economic and social factors, including paradigms, goals and values. And we've broken this down into these 4 elements, such as governance. This looks like a lot of buzzwords, but if you reflect about them, these are exactly the main points. Governance has to be integrative, inclusive, informed, such as using scientists, adaptive, multilateral, cross-sector and preventive. If we think about governance here, at the company level or at the political level, then there is a lot of room for improvement. Then it's about incentives, investments for sustainable and responsible innovation, a reduction of subsidies in non-sustainable business. This also includes the common agricultural policy, and also considering the costs and consequences for remote regions. The narrative is the vision of a good life which promotes responsibility for nature and the common good. The aspects of that is the global sustainable economy, which goes beyond the key performance indicators and which has a global view of holistic, long-term perspectives for quality of life. These were the core messages of the global assessment. And since there's some time, I would like to also talk about the COVID-19 and biodiversity. This was one chapter in the total report. The total report has 1,600 pages. 2 or 3 pages of that concern COVID. And for reasons of topicality, we thought it would be a good idea to also make a guest commentary about this subject, COVID-19 stimulus packages, which are supposed to save lives and reduce risks of pandemics. So at the end of the presentation, which you will be able to download, there is also a link with this document in various languages. But the main statements about this are that the recent pandemics are the direct consequence of human activities, just like the climate and biodiversity crisis. So it's all symptoms of the same basic phenomenon. More than 70% of all new diseases have their origin in wild or domesticated animals, such as malaria. Pandemics arise if more people come in direct contact with animals which carry these pathogens. It sounds trivial, but it's still important. And globally, we have got ideal conditions for pathogens to jump from animals to humans. For example, deforestation, the expansion of agriculture, the intense use of land, especially cattle breeding, the reduction of wild species and the habitats of the wild species, for example. Our virus used to be harmless, circulated amongst bats. Now we've got 4 million people infected, and business and social life has come to a standstill across the globe, and human influence has contributed to the rise of pandemics such as COVID-19, for example through unregulated trade with wild animals and the explosive increase of air travel. also the close contact with between wild animals and domesticated animals. So COVID-19 could only be the beginning. Zoonoses have caused more than 700,000 deaths per year. Sometimes this fact is being ignored, and the potential for future pandemics is much larger than we would have thought. In mammals and water birds, there are 1.7 million non-identified viruses which could infect humans. So every one of these viruses could cause a disease X, the next disease X, the next COVID-19. There will be such a disease X. The question is whether it will be as disastrous as COVID-19 for the future. Pandemics will become more likely, they will spread more quickly, they will have even more economic impacts and kill more people. The measures which reduce the effects of the pandemics, of course, should not increase other crises. That's very important. And we've mentioned three important components for these stimulus programs and rescue programs for business. The first thing is that these laws to protect the environment must be maintained and strengthened. There should be only stimulus packages which create a stimulus for sustainable business. Then there should be changes to the support of agriculture, air travel, and so on. Otherwise, we would subsidize the rise of future pandemics. The second principle is the One Health approach. So we have to understand that the health of humans is inextricably linked with the health of animals and plants and the environment at large. We have to avoid a situation where public health systems are overloaded as a result of deforestation, for example, and of profit making. And the third principle is that there should be a behavioral change and the pandemic risks are reduced. And it's all about sustainable long-term alternatives to risky economic activities. The summary is for the COVID-19, relevant for the COVID-19 subject, but also for the global assessment, is that we depend on functioning ecosystems, but we have been modifying these ecosystems. The trends are worrying. We've seen it for animals, for biodiversities, but also ecosystem functions. But there must be transformative change. The challenges of climate change, the worsening of nature, and the achieving of a good quality of life are connected with each other. They have to be attacked synergistically. There are many successful examples, but these challenges cannot be solved on a small scale. And we need a quick implementation of existing instruments and bold decisions to achieve transformative change. At this point, I would like to stop here. There are more slides, but you can download them for yourselves about the global assessment and reading. Thank you very much. Thank you very much, Mr. Settele. And we'll get started with a discussion. And in this discussion, initially, we'll have a discussion between the different presenters, and then we'll pick up on questions coming from the listeners. So I'd like to start with the first one, a question to Sabine. If you compare these two presentations, it becomes quite clear that the health aspect comes very much to the fore in both presentations, and the only chance of addressing this is a synergistic approach or planetary health approach. When I started being committed in the field of climate change and health, I was surprised to see that amongst the climate researchers, the climate NGOs, the health dimension has been completely missing. So maybe, Sabine, you start giving us your comments, and maybe you can also give us your take about the differences and the commonalities between both presentations. Well, there are clear links, obviously, if you think about therapy. So what are we going to do in view of these problems? And there are discussions which go just in one direction and just focus on climate only. And there are crazy suggestions such as we should have forest plantations across the world, and then the wood can be burned and the carbon can be sequestered. We don't really bear in mind that we need this land for food and for biodiversity, for example. This is a question, Stefan. In some of these models of IPCC, is already integrated that the carbon can somehow be sequestered, although this is technically still new. So it gives us the idea that we can still make it even if we are slow off the marks. But of course, time has really gone very quickly, and even with these sequestration ideas, it is too slow. But Greta also says in her presentation that these tipping points, these are very important. In medicine, it's quite clear what the tipping point is. 37 degrees of body temperature is okay. 38, we don't feel good. 39, you're ill. 42, you are dead, or the circulation collapses. So this should also be brought in, and also the sequestration idea. That's interesting. What is this word for this for binding the carbon? Sequestration. Exactly. So whether that's already integrated and whether these tipping points are integrated and factored in, and whether there are more risks than meets the eye. Well, in these models by the IPCC, in which, well, in the various emission scenarios, but for the very low Paris-compatible scenarios, they are promoted by economists, energy experts, and so on, not so much by social scientists or by climatologists. And they do, indeed, factor quite large quantities of negative emissions into these climate protection scenarios, so-called negative emissions, which is the active removal of CO2 from the atmosphere. And one possibility is to produce bioenergy combined with carbon capture and storage. Carbon capturing is technically possible. There are some systems available, up and running, but it's expensive. And to my knowledge, I don't think the price is compatible with the renewable energies, which are becoming cheaper and cheaper. So there has been test plants which have been stopped, actually, of carbon capture and storage. It requires a lot of energy, and this makes it expensive. There are some other technical ideas, direct air capture, so without creating biomass first, using plants to take the carbon from the air, which is even more difficult, technically speaking, because we're talking about the fact that the CO2 is diluted. It's only got 400 ppm, which is 0.04% of the atmosphere. So it's a very dilute a trace gas, and extracting this from the atmosphere can't be so easy. So that's the second law of thermodynamics, that you really have to input a lot of energy for that. So I don't think there are any such technical options on the horizon, and using large bioenergy plantations. We've heard about this in today's seminar. These options are very limited because of the fact that the land surface is limited, and there's a competition with conservation and agriculture and so on. But also there are other planetary limitations, such as the availability of water, the water stress, because in order to create bioenergy plants and to plant them, to cultivate them, you need to irrigate them. And the question is, where does the water come from? And the water will be missing elsewhere. So I do think that within this IPCC scenarios, the figures are over-optimistic in terms of the negative emissions which you can then achieve in the second half of the century in order to compensate for the sins we are committing in the next 30 years. So what counts is to act now in the next 20 or 30 years to bring down emissions, and not to ask our kids and children and kids' children to do that for us, to produce negative emissions and to extract from the atmosphere what we have emitted in excessively now. So that's not the right approach. So both Rahmstorf and Settele are saying that the pressure to take action now couldn't even be higher than now. So there is now no possibility of postponing the action. Mr. Settele also mentioned transformative change. In your group, did you also discuss the role of social actors such as we do? So the role or possible role of doctors or carers, medical professions, to make sure that there is transformative change. Well, of course, we have discussed this is a question of the overall society. Everyone plays a role. Of course, every individual plays a role to be committed and to do something. And this will only happen if there is enough pressure from the bottom, such as in Fridays for Future, to make sure that the willingness of doing things will happen at the political level. So pressure from the bottom is important. So both aspects are important, both bottom up and top down. But this will only work if the society at large will play ball. As in the case of the coronavirus, if the community agrees, then you can take action, you can make laws and so on, top down. But this will only possible if everyone plays ball, if everyone is equally concerned. So this is based on people having volunteers and voluntary activities. And if the community at large agrees, then the politicians can come up with these laws. And then you don't feel as powerless as an individual. So we need the community. In recent years, we've seen the increase of the success of the Fridays for Future movement. Did you expect anything like this happen? No, we didn't really expect it, but I was positively surprised because this went hand in hand. It really coincided with Paris, basically, and there was a great cooperation, really, between this movement and our initiative. I'm quite pragmatic there. We're talking about the same phenomenon. The climate is, of course, a very broad subject. It's easier to communicate that than biodiversity, but it's really a twin crisis. Greta is also doing lots of statements about, but she's not just talking about climate. She's also talking about biodiversity. But these two movements are in close contact. So whenever there are requests, then I'll pass on the information. And I think there is a very good coordination between the two movements. It's really a joint movement. It's of course difficult in the corona times because the visibility of us is reduced. There is a possibility for viewers to ask questions. Lisa collected these questions, and therefore maybe Lisa, you can ask these questions. Yes, I'm Lisa, Louise and myself. We have been moving around in the question and answer session, and we've tried to answer as many questions as possible. There have been 70, 80 questions. Thank you very much for those. We're going to put our heads together with the speakers and come up with a written answer to those questions. But one question which was interesting to people was the link between heat and death. So how heat-related deaths were defined, and what are the actual diseases people will die from under those circumstances? I think this is a question for Sabine, really. I can only mention the Gasparini study, which I showed, and the figure of 70,000 heat-related deaths in the summer of 2003. This is the excess mortality, is the all-reason mortality, which is higher on hot days than on cold days. And it was calculated as that over the period of time when there was this heat wave. And I showed this peak from Moscow where if you look at the curve, you simply create the area under the curve, and then you see that in this period in 2003, there was a peak in the mortality figures in Germany, also in France. And you could come up with an estimate, the same as Financial Times does it with excess mortality during the COVID crisis. How many more people, additional people, have died? And of course, there is some background fluctuation, but there is a big difference over the background fluctuation, so we're quite safe to say that there is this number of excess deaths. Sabine, can you come in also? Well, you can also calculate as to whether fewer people died later, which died earlier in these heat waves. What are the diseases people die from? Of course, there is a heat stroke thing, which is not the big bulk of people. Most people die because they already have underlying heart problems, lung problems, other diseases, or older people whose circulation is not as stable, and they simply their health fails in the heat. Maybe, Sylvia, you can say also a few words on that. You're quite right, Sabine. And also, people don't drink enough. Older people or children, people with psychological diseases, they don't have the feeling of thirst. And they maybe sometimes rely on the help of others. They don't drink enough. They die from kidney failure. And something which is also interesting is the interaction with drugs. So you can say that certain drugs, such as diuretics, which increase urination, they would have to be reduced because this would increase the risk. But we'll have a separate appointment, or really second cycle of academy presentations on this subject. And yes, on the third round. And there is also a scientific working group on the same subject, because we assume that even this year there will be a heat wave again. And so far in Germany, there are plans, action plans, in order to protect people's health, but they are somewhere in the drawers of centers, governmental centers, but they haven't been rolled out publicly. So we're going to have a focus subject, and there will be some webinars by KLUG about this subject, and we're going to come back to the subject. It's a great example of where the risk is very clearly defined. Many of the measures to be taken are quite simple, but you have to bring people together in the communities, you have to train them, and you have to plan for it. Who is going to be most at risk, and what are we to do about them? This is about the implementation. Well, we can protect people now, but it's important to discuss this subject now, because if you look around in your acquaintances, there are grannies and granddads who are concerned even now. It concerns hundreds of thousands of people who are suffering from heat exposure. And that's important. It's important to discuss about it and raise people's awareness for it. Lisa, what other questions do you have? Well, Professor Settele, a question about biodiversity and the current corona pandemic. Can environment protection prevent future pandemics? How about animal husbandry and the link with that? And what are the possible solutions there? Well, the link clearly is that when it comes to deforestation, for example, we are reducing biodiversity in the favor of less dominant species, which then make it more likely for viruses to spread. And here the likelihood of this jumping across to humans is higher. And biodiversity has a preventative effect, has a dilutive effect. So if I have more species, then the chances of one virus to spread to one dominant species is reduced. So making sure that there is more diversification, that's always very good for health, or for fighting pandemics. And in animal husbandry, well, we had some influenza events starting from pigs. So even in domesticated animals, there is a risk for viruses to spread. also to humans. I think this is also true for Ebola, involving dromedaries in Africa. And there are also there's swine flu and other viruses coming from Eastern Europe involving domesticated animals, and here mass animal husbandry may have a negative impact. Of how to prevent it? Well, you can prevent it by having masses of people, masses of animals in the same space, same confined space. That's one problem, and you should prevent that. So we have to try of working on agriculture, being more conservative there, not expanding agriculture more, not intensifying animal husbandry more. And then the question of connection. We have more air travel now, which also contributed to the fact that the virus has reached out to all corners of the earth. So we have to reduce the intensity of exchange, of human encounter. One concrete measure would be to control trade in wild animals. That's absolutely key. There is a lot of illegal trade, illegal markets, which absolutely need to be stopped. This sounds very straightforward, but it isn't very straightforward. Even in China, it hasn't been possible to do. Complete bans are difficult because there are some regions where the wild animals are important for local diets. So it's not a silver bullet solution. There are no silver bullets, but there are solutions which are good for the health of animals and also good for humans. Another last question to both of you. How confident are you that politicians will follow the scientific recommendations? Because the research results have been around for many years. And in terms of the pandemic, people are listening more to scientists. Scientists are more visible in the media. And how confident are you for the climate question? Well, that's a very difficult question. I don't really ask myself this question, actually. It's not really about making a forecast about my confidence, but I simply have to make sure that something happens. Like a surgeon, if a surgeon is undertaking an operation, open heart surgery, he will not or she will not think about whether this will be good or bad, whether the patient will live or die, or whether the likelihood of 20% or 40%. The surgeon will do their very best to make sure the operation is successful, and this is what all scientists should do. I would also like to come in there. We are doing all this because we think we'll have an impact, otherwise we'll not be committed at all. It's not in our nature. I think we have to move many other colleagues to become more active in this respect and really spread the word amongst the general population. But whether I'm optimistic or not is not decisive. As long as we live, as long as we have a chance of surviving, we have to work hard for that. Well, I think it's great for you to give a medical example rather. I also like medical examples. If the likelihood is 20% that a certain therapy is successful, who would not try this therapy? And here it's about the survival of mankind. Why shouldn't we do our very best as long as there is a non-zero chance to make it happen as well as we can? It's not just a yes or no in this respect. Well, giving up, throwing in the towel is not a possible reaction for us. I think the question fits the motto of this series of presentations very nicely. From knowledge to transformative change. We've received a lot of knowledge today from two key areas. It's quite clear. Unless we also pass on to transformative change, there will be no good. And transformative change means that even in unlikely settings, we have to work wonders, not just do something which will happen automatically, but get something going. Although it doesn't seem very very promising. And this means we shouldn't really stare at politicians. We have to make sure that we have to change politics. And this could be 17-year-olds or 70-year-olds. It could be lay people or doctors. It's very important. We don't need a majority to initiate transformative change. It takes a minority to really join forces and create partnerships and learn together as to what is possible and how to do it. This means that we have to stay connected between the key scientists and also knowing that they can't do it for us. We can only do it together. That's really the motto for the whole series of presentations. But it's always important to do it on the basis of what the best scientists have found out. And that's why I'm very thankful for both of you to have given us your time. I'm sure we're going to meet again and dealing with each other again, because we are basically one movement facing up to this challenge and making sure that good life is possible and what we can contribute to achieve that individually and together. This is really the whole message behind the whole series of presentations. I would like to point out to the next seminar, which is about the planetary limits and health. Claudia Treidel-Hoffmann from the TU of Munich is talking about that. Mr. Hoff and Mr. Gunka, who is a heat psychologist and physiologist from Charité. This is about the global context, and also it's about the consequences on Germany. And this will be building on what we've heard today. So my invitation is for you to attend that. I also would like to invite you to ask all of your people in your environment to participate in this effort. What we've done today will be available on the web tomorrow, and we'll also provide materials for the presentations. Maybe we'll ask you to provide 1 or 2 key texts which we'll upload. And also let me remind you that this series of presentations lives or thrives on discussing things together and looking together at where in your environment are there some good ideas. That's also important. Transformation is not possible in a one-off effort. It takes a lot of different people, a lot of different efforts. Just like 5 weeks ago, we had the idea of creating this series. We wouldn't have thought that we've got more than 1,000 people following us today. Okay, Sylvia, have I forgotten something important? Not really, thank you. We would be pleased if you could join us next time around. And so I could like to second what you said. So thank you very much indeed to the speakers. We're going to continue working with each other. And thank you very much for listening. We're looking forward to the next few times and hoping for your bright ideas and questions. Sabine, you'll always be around. You're a key person for all our work, and so enjoy the rest of the evening. Thank you to the organizational team and for the technicians. Thank you very much.